Hey there, and welcome to lab number 4, where we're going to be investigating some chemical reactions of copper. So this gives us an opportunity to actually practice with our formula writing as well as balancing chemical equations and also looking at different types of reactions. So let's go ahead and get started with the procedure. All right, step number 1 says to place 25 drops of copper 2 nitrate into a test tube. So I'm coming close to counting. 21, 22, 23, 24, 25. All right, that's good enough. To that, we're going to add sodium hydroxide. So you can see the copper solution is clear and it's blue. Very pretty, huh? That is the copper 2 nitrate. Now, as I add the sodium hydroxide, that's probably best to get some sodium hydroxide in the dropper first. Okay. All right. Now you'll notice that we've created a blue precipitate, we call that. It's a solid kind of suspended in the liquid right now. That blue solid is actually the copper 2 hydroxide we formed in this reaction. We call that the precipitate. The solution that remains behind is called the supernate. And if I were to let this sit for a while, the copper 2 hydroxide would actually sink to the bottom of the test tube. But now you can see that reaction has taken place. So why don't we pause here for a minute, think about this reaction, let's write it down and balance it. We took a copper 2 nitrate, reacted it with sodium hydroxide, we created a copper 2 hydroxide and a sodium nitrate. Go ahead, balance that equation, and then come back for step number 2, reaction number 2. Okay, so for reaction number 2, we're going to heat this copper 2 hydroxide we formed in a boiling water bath. So right here, I actually have some hot water sitting on a hot plate, and we'll be able to see what happens when we place this copper 2 hydroxide in the nearly boiling water. So let's give this a few minutes. You can take a look at this reaction for reaction 2 as it's not anything we're going to add. The heat itself is helping propagate this reaction, but our copper 2 hydroxide is going to be forming a copper 2 oxide, and we'll get some water as a byproduct too. So reaction 2 is taking the copper 2 hydroxide and turning it into copper 2 oxide with water. There's reaction 2. We'll take a look at the product here in a minute, but in that meantime, why don't you go ahead and pause and create a reaction for the copper 2 hydroxide forming copper 2 oxide and water. Go to it. All right, after about 5 minutes of time, we can remove our copper 2 oxide that's formed. Now you can see that it's now a black solid. And again, the same idea would apply. If I could let this sit for a little while, it would actually precipitate out. I can already see clear liquid starting to suspend above that precipitate. So it's very insoluble. I'll let that sit for a minute and we'll take a look at it as it settles. But again, this is the copper 2 oxide that formed from our copper 2 hydroxide in the previous reaction. All right, now we can see we have a nice separation, the copper 2 oxide sinking to the bottom. You'll notice the solution is now clear. We started with a blue solution of copper 2 nitrate. That turned into a blue solid of copper 2 hydroxide. Now we have a black solid of copper 2 oxide, but the solution is clear. Where is all the copper right now? Where do those copper atoms go? That's something to think about. All right, our next step, we're going to add hydrochloric acid to our copper 2 oxide. This is going to form a copper 2 chloride in the process. So let's take a look at this. Nothing really exciting yet. All right, maybe little stirring will help matters. Whoa, Nelly! Isn't that neat? So now we have turned this into our copper 2 chloride, and you'll notice again it's got a pink tint to it. It went from a black solid to now what is copper 2 chloride being blue again. So where are our copper atoms now? Obviously they're back into the solution. How fun. Let's pause for a second and think about this reaction now. The hydrochloric acid reacted with the copper 2 oxide to form what? The copper 2 chloride and water. Gives you the opportunity to balance reaction number 3. Go ahead and do that. All right, for the final step in this lab, we're going to take this copper 2 chloride and react it with some aluminum foil. So just the same aluminum foil you would use at home. I'm going to go ahead and drop this in, and we're just going to let it sit for a while. Ooh, I'm seeing a little bubbling going on. It's kind of a side reaction. And you might notice it's starting to get dark. What's happening to that aluminum? It's really going nuts now. Looks almost like it's turning red. What the heck? Why would this aluminum foil be turning red? Wow, that's a beautiful red color. The bubbles are actually a side reaction that's taking place. The hydrogens in the hydrochloric acid are being reduced down to hydrogen gas. But there's obviously something else that's happening. That's not our main reaction we're looking for. We're talking about the copper chloride, copper 2 chloride, is reacting with the aluminum to form, excuse me, what would that form? An aluminum chloride, and you guessed it, the red stuff is what? That's pure copper metal. You'll notice the solution, excuse me, the solution is losing its blue color. Why is that? Where did the blue color come from? Well, think about where's the copper? Where did the copper atoms go now? Well, obviously, we know that copper is a red metal. Look at that stuff. Wow, a nice clear solution and a bunch of red solid copper metal formed on the top. That's a beautiful reaction right there. So now we finish with a colorless solution and a whole bunch of copper metal. So again, the reaction. Copper 2 chloride with aluminum forms aluminum chloride and our beautiful copper metal. So that finishes the 4 reactions we were going to demonstrate today. There are different types of reactions. We have synthesis reactions, we have decomposition reactions, we have single replacement and double replacement reactions. There's also combustion reactions, which we'll talk about. But see if you can classify based on your balanced reactions what type they are. Also, we saw some solids formed. We had some things that were dissolved in the water, which were aqueous. We have some things that were perhaps liquid at some point. Did we? Well, not really. I guess we did have water forming. Water was obviously in the liquid phase. We can then denote that using the L, G, S, or AQ notations. And I hope that was entertaining for you. You got good practice at coming up with chemical equations and balancing reactions. Kind of neat. And I would like to thank you for stopping by. I will see you when I see you.